We will discuss now about waveform generation using 555 timer. The aim is to check the table operation of 555 timer, that is a free running multi-vibrator. We will use now it in the monostable multi-vibrator mode. We will now check into the design for monostable mode. Here the TP, that is for the positive timing for the positive pulse, is 1.11 RA into C. The design for a monostable multi-vibrator, TP is equal to 1.1 RA into C, and the time delay we are considering is 1 microsecond. So let us select 1 millisecond. So let us consider the capacitance to be equal to, or we select it as 0.1 microfarads. Therefore, substituting for TP is equal to 1.1, TP is equal to 1 millisecond, C is equal to 0.1 microfarad, we get RA equal to 10 kilo ohms, the standard value. The voltage, now we will consider VC, that is across the capacitor, is equal to VCC, we would have given as 12 volts. 12 volts, 5 volts, VCC is 5 volts, and 2/3 of it, I will show you where it affects in the circuit. And TP is equal to 0.1 microsecond, 0.1 the microfarads, this is the capacitance, 10 kilo ohm resistance into 1.1 gives you 1.1 millisecond. This is the circuit diagram for monostable multi-vibrator using 555 timer. You can see now we have the 555 timer. Its first terminal is connected to ground. Its second terminal is connected to the trigger or trigger input. The third terminal is output. The fourth terminal along with the eighth terminal is connected to VCC, as well as the other end is connected to RA. The fifth terminal has a capacitor 0.01 microfarads. The sixth and the seventh terminal are shorted together and are connected to the other end of the resistance RA, and at the same junction we connect the capacitance C equal to 0.1 microfarads, and the other part is connected to ground. This is the part where we are going to see the value of VC, the voltage across the capacitor. This is the internal circuitry of monostable multi-vibrator, that is in the 555 timer. 555 timer and the multi-vibrator connection. We can see the input is VCC, which is 5 volts. You have got the potential divider, 3 resistors, and with the junction, all the 3 are equal, and their junction giving you 2/3 VCC and 1/3 VCC. They are connected to the 2 comparators. The output of the comparators is given to the flip-flop, and one output is given to the transistor, and the other output is given here for the output voltage. The other is given to the reset. Now you can also see we have connected, this much will be the 555 timer, to which we have connected R and C. RA is what we had called the value as 10K and C as 0.01 microfarads. Let us view the input and output waveforms. When a trigger input is given, you can see this is the total time period of 1.1, and its magnitude is plus VCC, and 0 volts, that is plus 5 volts. The output waveform, then the capacitor waveform, you can see is here. Its magnitude will be 2/3 of VCC, that is approximately 5 into 2/3, about 3.6. Next we can see the output waveform, which will also be approximately equal to 0 to 5 volts. Here we have to recognize that at the negative trigger pulse is given, and then this has to, when the capacitor is charged up to something, we get the output waveform that is brought down, and it stays low as long as the capacitor is discharged. Again, when the capacitor gets charged, it gets high and it goes up. Now about the circuitry. This is the 555 timer chip which we will connect for monostable mode. Terminal 1, this wire is connected to the ground. There is also another wire coming from this position to the ground. Terminal 2 is connected for a trigger. It is connected for 100 Hertz trigger. So 1 by 100 is equal to, you can get the timing in milliseconds. Then the third terminal is connected to the output. This is the output that we are going to take, and it is connected to the CRO. The fourth terminal is connected to two places. One is it is connected to terminal 8, and the other place it is connected to a resistor. So you can see here, this is the wire that is connecting 4 and 8 are shorted. The other wire from 4 is connected to the one end of the resistor RA. The other end of the resistor RA is connected to the capacitor, and its capacitor's other end is connected to the ground. There is another, from terminal 5, it is connected to the capacitor C, which is also grounded. From terminal 6, we have connected it to the junction of RA and C. And 6 and 7 are shorted, and 8 is connected already as shown to 4, and the other end of 8 is connected to VCC. This point in the digital IC trainer kit represents 5 volts. Procedure to conduct the experiment. Rig up the circuit as per the circuit diagram, which we have already done. Next, switch on the DC supply VCC and VE, then an AC input supply Vin, and the CRO, which has got probes tested and connected. Then observe the waveforms and compare the practical and theoretical values of TC and TD, that is the two parts of the waveform, the timing of the waveform. Then bring back the switch off the digital IC trainer kit and switch off the supplies. I have switched on the DC trainer kit. I have connected it for monopulse generator. Then the circuit is working. We can see on the CRO, this is the output waveform and this is the capacitor. You can see as the capacitor is charged, it is at the high position, the output is high, and when the capacitor is discharged, the output comes low. Both are in low condition. Again, when the capacitor gets charged, the output goes to high. This is a repetition. Output taken is as follows. This is the monostable 555 timer. This is the voltage that was given for the timer in the trigger pulse. This is the voltage across the capacitor. You can see 1.2 milliseconds. It is getting charged to a maximum of 3.6 volts, which is equal to 2/3 VCC. And as it is getting charged, we can see output is also rising high. It has to be equal to VCC, which is equal to 5 volts, but due to experimental errors, we are getting it as 4.8 volts. And the charging timing is 1.2 milliseconds. TP is also 1.2 milliseconds. Within the experimental errors, we have got the timing. Then this is Td, the delay time, which is equal to 4.1 milliseconds.